Hello, in this video, we will be discussing about the preparation or synthesis of alcohol. Okay. The alcohol can be synthesized or prepared by different ways. And some of these methods that you have already learned in your organic chemistry 1 by, for example, one method of preparation that we can say is about the by nucleophilic substitution reaction of alkyl halide. For example, if you have some kind of alkyl halide like alkyl iodide, and you can react that with the nucleophile like the OH minus, so that is what will substitute for iodine, and you can prepare the alcohol. And this you have discussed in previous chapter in organic chemistry 1. Okay, this is by SN1 and SN2 reaction we can prepare the alcohol. The other very important method of preparing alcohol is by the hydration of alkene. When we say hydration of alkene, that means hydration meaning the addition of water in alkene that result in the formation of alcohol. Now for simple example here, see, if you have some kind of alkene, then we can add water across this double bond, uh, but this addition of water takes place only in presence of some acid catalyst. Okay, without this acid catalyst, the reaction will not be successful. Therefore, you can also call this as the acid catalyzed addition of water. And when we add water in presence of acid catalyst, the addition takes place by following the Markovnikov rule. So this water means HOH. Hydrogen will go to the carbon containing larger number of hydrogen, and OH will go to the carbon containing less number of hydrogen. Okay, so hydrogen will be added to this terminal carbon, and OH will be added to this second carbon. So that is how you can uh, get the secondary alcohol. So this is the um, hydration of alkene or addition of water across the double bond. However, so this is part number, this is A, one method of adding water across the double bond. But if we have some kind of alkene, say we can see this example. This is one unsymmetrical alkene, and if we add water across the double bond in presence of acid catalyst H plus, then we would expect this water to be added across this double bond, and expected result would be like following the Markovnikov rule again, hydrogen adding to the carbon containing larger number of hydrogen, and OH would be adding other second carbon. But however, this is the expected product, but this will be only as the minor product. This will be only formed as the minor product. So in presence of acid catalyst, this there will be the carbocation rearrangement can happen, and the major product is going to be hydrogen adding here, whereas the OH will be added into the uh, next carbon because of the carbocation rearrangement by the what we call hydride shift. This is the product formed by carbocation rearrangement rearrangement and that happens by hydride shift hydride shift and that is when you will get the uh, tertiary carbocation, and the OH will be substituted on this tertiary carbon there. So that is what your product is going to be. Okay, so this is the unexpected. So when we add water across the carbon carbon double bond in presence of acid catalyst, there will be the rearranged product can be formed. Okay, it will form the rearranged product, or unexpected product will result. Now, but we can avoid this rearrangement by using other process for adding water, what we call oxymercuration or oxymercuration demercuration. Also, you can call this as oxymercuration reduction. So this process, in this process, what do we do here is we use the alkene and the addition of water. We follow by using number one reagent mercuric acetate, that is when it will be oxymercuration, and of course we are adding water, and you can use THF here as the solvent. And the second one, so this oxymercuration process will avoid the rearrangement. It will follow the Markovnikov rule but will avoid the rearrangement. But now you need to do the, once you do the oxymercuration, you need to do demercuration or the reduction. That is when you need sodium borohydride, NaBS4. That will that will do the demercuration part. So in this, if we use this oxymercuration reduction, there will be again addition of water across this carbon-carbon double bond. It will follow the Markovnikov rule and it will prevent the rearrangement. So hydrogen will be added to the carbon containing larger number of hydrogen, and OH will be added to the carbon with less number of hydrogen. So this will, again, the oxymercuration reduction, that will avoid rearrangement. Even if possible, the rearrangement will be avoided. If not possible, then there is no question about that. But even if the rearrangement is possible, that will be avoided in oxymercuration reduction. So whenever we need to do the hydration, uh, avoiding the rearrangement, we need to follow through oxymercuration demercuration or oxymercuration reduction. These are the reagent that is to be used. Mercuric acetate, of course water we are adding, and for the demercuration part we use sodium borohydride. Now both of these, acid catalyzed addition, so this is the addition of water as the acid catalyzed addition. Okay, acid catalyzed addition and oxymercuration reduction, both of those processes are following the Markovnikov rule. Now, if we need to add water, okay, by following the anti-Markovnikov way, okay, so it's still other way of adding water by if we want the anti-Markovnikov Markovnikov's rule to be followed, then we use the other type of addition. We call that as the hydroboration oxidation. Anti-Markovnikov addition of water takes place by what we call hydroboration oxidation. Now in this process, let us use again the one unsymmetrical alkene. Now we wanted to add water across the double bond, but we wanted to do the addition of water by anti-Markovnikov rule. Then the process you got to use is hydroboration oxidation. So for that, you got to memorize some of the reagent. Number one, we need to use BH3. We call this as borane. Okay, and of course we are borane, and this reaction can be done in presence of the solvent called THF, And this reaction takes place in basic conditions. So OH minus some kind of base like sodium hydroxide, potassium hydroxide we use, and this is the oxidation reaction. So this reaction requires some hydrogen peroxide as the oxidizing agent, because this is hydroboration oxidation, and of course it is addition of water, so you need water. These are the reagents that we need to remember. And in this case, the addition takes place by following anti-Markovnikov rule. So hydrogen will go to the carbon with less number of hydrogen, OH will go to the carbon with larger number of hydrogen. So this is how it will be added, right? So, and by the way, this in this hydroboration oxidation process, both hydrogen and OH, those will be H and OH will be added in cis addition takes place. Both will be added in from the same side. So that will be very critical when we are using, say for example, we have uh, this kind of alkene, and we are using number one, say boron, and in presence of THF as the solvent, and of course we are doing that in the basic condition in presence of hydrogen peroxide, and of course we are adding water. Then the result here is, again, we will add the H and OH across the double bond. It will follow the um, anti-Markovnikov rule. So the hydrogen will go to the carbon with less number of hydrogen. Say for example here, this is where the hydrogen will be added, and OH will be added to the other carbon containing larger number of hydrogen. So both, see, the OH and OH, they are added in the cis way, okay, cis fashion. So that is the what we call is the anti-Markovnikov addition of addition of water by the hydroboration oxidation. Okay, these are the three very popular way of adding water, or we call that as the hydration of alkene. All are addition of water across the double bond. Very important discussion. This is what here. Now the next one, the in the alcohol topics, we can also add about the preparation of a diol. Diol means two OS group across the double bond. So diol is also the alcohol containing two OS group. So how can we prepare that? So let's see. In this case, whenever we have carbon carbon double bond, and we can add two OS group across this double bond by the what we call is the reaction called hydroxylation, and we call that as syn hydroxylation. Syn hydroxylation means adding two OH group from the same site, called syn hydroxylation. There are two processes for that. One, by using the reagent called osmium tetroxide, OSO4. Okay, osmium tetroxide, and the reaction usually takes place in presence of hydrogen peroxide. Then what is the result here? You will add two OH group across the double bond. Both OH group will add from the same side. We call that as syn hydroxylation. So that is how you will get the diol. The other method to prepare for the syn hydroxylation is, again, using the cold and dilute KMnO4, potassium permanganate. That also will add the two OH group across the double bond, and will add both OH group from same side. We call that as syn hydroxylation. So these are the two methods, either using by osmium tetroxide. This reagent is called osmium tetroxide in presence of hydrogen peroxide, or by using cold and dilute potassium permanganate. That is how you can prepare the diol. All right.